Alright, let's screw around this thing for a good hour plus. And then lock that better. So I got some bolts in here now to mount up. We're 800ths out wide, all the way even. So now it's all in there nice and even all the way around. And I put the 5/8 of an inch gap in here. The height difference between this case here and this one over here, which is a 120 motor. The up and down from here to here. So that's the 1.5 inches from here to here. So I got that mocked up where the cylinder is going to sit. So now I got to figure out what the rod's going to be. Here's the piston we're going to use. So I got to measure from the center of the hole here to the bottom and center of the main bearing and calculate my differences to get overall length of what rod length I need to make this work. And we'll see if that's something I can buy or not buy. Custom made parts suck. Alright, so I'll lay this on its side right now. Of course it's not laying very even. There we go. Eyeball everything to see if it's halfway close to being square and straight. Looks like we're pretty close to straight. We're definitely bottomed out on this. Check our deck squareness here. Oh, it's pretty close. Alright, so that should give me a decent amount of offset. Here's our piston. Gonna move this over, get some support for the piston now. Something else we gotta do, right? Okay, lay our piston in here. Walk nice little roll. Okay. So now we're even with the flush with the top of the cylinder. That's our compression height. So we're actually a little bit lower right now, but it's not square either. So bring it a little bit closer. Whoop. That's probably closer to being real. So I measure the center of the wrist pin, the center of the hole. Take your rod, your crank stroke out, and that's the length of rod you need. Pretty straightforward. Nice even dimensions, so you don't have to worry about figuring what the hell you're trying to do. Just measure it as best you can. So center of the crank is about there. 11 3/8 inches is roughly what we're coming in at. So you take off your crank length, which is 4 1/4, and so 4 from 11 is 7 inches, 7 1/8 inch rod, roughly, if I did my math right. Used to have a calculator in here somewhere. I think that's long disappeared. Didn't use anything. Oh yeah, who knows where the hell that thing went to. Okay, well, the easiest way to tell is, okay, 11 inches, take 4 out, 7 inches. It's definitely 7 1/8 inch rod. And I'll make a 7 1/8 inch rod. So we got an oddball combination. So we gotta run more stroke. Or we're going to run a shorter cylinder. Now, we really need a longer cylinder because it's easy just to make more stroker plate. You need to go up quite a bit. So, the 7.680, I think, is twin cam length. That's 780, 7,780. Yeah, anyway, somewhere around 7. So figure 8, 7.8. We're at 7. We got 600,000. We got to put 600,000 more in the deck, roughly 5.5 to 600,000. So making the motor taller will take care of that problem. The shortest rod you can get, I think it drops all the way down to 7.5 inches. Well, we're at 7 1/8, weren't we? Yeah. What's Harley rod? Harley rod is 7.44. So we're stock rod length. How did they come up with that number? I thought that cylinder was taller than stock. That doesn't make sense. Oh, dumbass. I put the whole stroke in there, not half the stroke. That'd be a 8.5 inch stroke. That's wrong. That's why the number's all bogus. Okay, so 2 1/8 inches we got to take off. So that drops us down to 9-inch rod. We have a 9-inch rod. That'd be really order. That'd be a real custom order part. So these cylinders are way too long for a short stroke motor. It's 11 3/8, so you take a eighth off. Leave you 11 1/8, 9 1/8 inches. Don't have that. Bad combo. We got to put more 9/16 more stroke onto it. So that puts us right about 5 inches. So these cylinders are made for long motors. Yeah. So the longest rod we can get is an 8-inch rod. So 8-inch puts us at 2 3/8 inches of stroke. That's 4 3/4 inches. So 4 3/4 inch stroke would make the work with parts you can buy these days. So that's going to be a problem. It's way, way too much. Trying to build a 120 motor, which is going to be a 4 1/4 stroke, not a 4 3/4 stroke. So somewhere we're going to make up a bunch of length. Alright, so what's the compression height of this piston? It's not very short. About 1.3 for 50 roughly. Maybe a little less. 300. Could be 300. It's not exactly a low number. So the problem these cylinders are made for really long stroke. They're 6-inch long cylinders, and normal cylinders are about 5 9/16 of stock. They're plus ½ inch. So that's what's hurting us, is that extra ½ inch of length. Trying to run a short stroke is just not going to fly very well. Oh well, I'll do some more measurements, make sure I'm right, but it looks like this is going to have to be, I'll have to cut a lot off that cylinder, or we're going to have to make it bigger, or get different pistons. Alright, there you go. Okay, I'm back doing figuring my length. I screwed up my dimension. We got the compression height here. We're not figuring in our length. No, that's... No, I'm not using that number. Okay. I just made another mistake. Okay. We got 1.3 compression height at the top of our cylinder. It's probably 1/280, but close enough. So we got 2 1/8 inches half our stroke, 4 1/4, and then 8 inches our rod length. So it's 10 1/8 is we want from center of this to center here, or you want 11.425 to the top of your cylinder to center here, because that figures in the compression height of your piston. Now we had 11 3/8 I think to our center line, which means everything's way too long. Again, starting to say I almost had it where it's working, but nope. So if we go all the way to our cylinder deck height, we max out our 12-inch indicator. And we're 12/080 maxed out. Looks close to what we need though. 12/100 maybe. So we want 11/400. So we're still, like I said, the same thing. We're 5 1/2 600 thousandths off. My dimension came up the same. So, and the difference in that height is in the cylinder. So the cylinder is just over 6 inches. 6030 or something I think it was. This 120 motor over here, if you measure the cylinder, it's about right there. Where's the head at? The head's right there. We're about 5 100, 5 100, 5080. So it's 5 inches. Or an inch longer. The length here is what's killing our height. You know, it's 1 1/2 inch more stroke in the thing, which is going to put you up there pretty high. So we're going to be, like I said, these things are made for 5-inch strokes and 5 1/4 strokes, 5 3/8. That's what these things are made for. And they use 8-inch rods, they use 8 1/2-inch rods, 8 1/4. Some guys use 9s. They vary. So 8 is a short rod for a big fuel motor. So that's why my dimensions are all screwed up. Too damn long. So if I want to use this cylinder, it's going to have to be shortened a lot. So you take some off your deck, but then you got to cut the sleeve. You pretty much got to take it all off the top up here. Now it's got this O-ring surface in here I don't like, so that can go bye-bye. That'll take a, that's 1/8 of an inch off right there. But we need to go half of this down. So let's see the height of this cylinder. This is 1 inch and something. 1 1/4 thick. So if you take a 1/2 inch off of that, it'd be 3/4 of an inch thick. Cut down to there. You gotta take some off your deck down here because this doesn't need to be 800 thou thick down here. You can take a couple hundred off that side and put it back up on this side, make it stronger. You gotta cut the sleeve off to compensate for the going down too far. That's how it works. So we're at 10 1/8. There's our dimension, and we were 1 3/8, I think is the number I had before, or 11 3/8. 11. There's 11 3/8. Center of crank, pretty close, and move that to a different angle location, and we're semi-close to that number. It's more accurate coming off the whole deck height. We're over 12 inches, so 600. I'm going to cut more than 600 off, almost 650 off. So, made a lot of cutting. It'll pretty well destroy that set of cylinders for doing a big stroke. But that's what it's going to take to make it work. So, you can't leave the deck height low because this 5/8 height here is what we need to get rid of, but the problem is that you can't get rid of that. You can't drop the cylinder down that low because the spigot's getting hit too hard. Everything gets in the way, it's too close. Because all the hardware shrinks down and touches each other. The cylinders here would have to be cut to here. You have to scallop the cylinder way to do that. So that's an option. You can try to do that. Do a lot of trickery, trimming. So that would be an option. Instead of cutting all this material up here, which would be nice to have, you have to angle cut this thing all the way. Instead of being angle cut right to this, you'd have to angle cut to here. Like that. And your two studs are going to be really close to each other. They'd be interfering with each other quite a bit. So that becomes, because that's 600 thou height you're taking as your thread material to thread the case with. You know, if your hardware is too close together, like this, when you get up here, you got room for thread. You get down in here, they hit each other. There's no room. That's what's going to happen. You take that 600 off, you're going to be, the bolts are going to run into each other. That's why you got to make the case taller. So, plus, it gives you room to put a center bolt in it, because you wouldn't have any center bolt if you did do that. So, pretty much got to make the case taller and then make the cylinder really short. Like I said, this motor over here, they got a 5-inch length. They got a little bit shorter rod in it. But, oh well. Otherwise, I gotta get a longer, lot taller piston. Compression of that piston has to grow by a ton, which makes it even more top heavy. Not good. So, shorten the cylinder is the logical way of doing it. It's too damn long. But, or build a bigger motor. Put a big 5-inch crank in that sucker and call her done. So that's the other option. So that is what I'll have to think about. I'm going to do a 5-inch motor. Didn't really want to do a 5-inch motor. So don't know. These are all unknowns. All right. Yeah, that's it for now.